Hey, Discrete Math students. Welcome to this Going Deeper video on the size and organization of truth tables. Now, you can probably kind of pick up as we do examples of truth tables, more or less how they're organized and what their size is going to be. But in case you want a little deeper background on why truth tables are the way they are and what might happen with a truth table that had more variables involved, well, then this video is just what the doctor ordered. So the type of logic that we have been working with in the class to this point, which is about day 4, is called propositional logic. This is logic that just involves simple statements and they are being combined or negated by connectives. So we have connectives involved, but nothing fancier than that. Not really quantifiers getting in there too much or anything like that. So here's a fundamental question in propositional logic, which we've been certainly addressing in class quite a bit. And that is, how is the truth value of a compound statement affected by the truth values of its component statements? We'd like to answer that question, and it turns out that there is a kind of definitive way to give a complete answer to it, and that is using a truth table. So giving a truth table, that's an explicit and exhaustive way to answer this question because it covers what happens in every possibility. It lists the truth value for the formula under every possible combination of truth values of the variables involved. Now, the truth table is going to have one row for each possible combination of truth values of those variables. And so if we ask the question, how many rows are there in the truth table? Well, that's really the same as asking the question of how many combinations are possible for truth values of those variables. Well, I think one thing that's pretty obvious, roughly, is that the number of rows is going to depend on the number of variables that are involved. As the number of variables goes up, certainly you're going to have more rows to account for all the possible combinations. Now, that's a broad answer, but we want to get more specific with it. Okay, we want to determine the precise number of combinations so that we know exactly how many rows our truth table is going to have. And we can do that with the help of a fundamental counting result. And that result is called the multiplication principle. We will be working more with counting later in the course, and the multiplication principle will be one of our go-to results to use in counting the number of possibilities or the number of instances of something. So the way that we tend to think about this, or the way that it's phrased in the principle anyway, is we have a sequence of tasks that we are going to complete one after the other. And there are a certain number of ways of completing each task. Okay, K sub I is going to be the number of ways to complete task T sub I. And we want to know how many overall possible ways are there to complete this particular sequence of tasks. And it turns out, as the name kind of indicates, the way that you get this is you simply multiply together the number of ways of performing each of the individual tasks. Now, this only works under the assumption that these tasks are independent. So independent, again, we'll get more into this later, but really what it means is that the number of ways of completing one task does not depend on how you completed the other tasks. Okay, so that number does not change. That's what allows this to be as simple as just multiplying these numbers of possibilities together. Okay, so let's apply this to truth tables, and let's start with a kind of specific example. So suppose that you have a symbolic logic formula, and it has 3 variables, P, Q, and R. We want to know how many possible combinations of truth values are there for P, Q, and R. Okay, so we've got, let's say we have 3 blanks to fill in here. We have to choose a truth value for P. We have to choose a truth value for Q, and we have to choose a truth value for R. So we're going to fill in each one of these blanks. I mean, we could choose something like true, false, true, something like that, but we just have to pick a truth value for each of these letters. Okay, so if we look at the number of choices, okay, the number of choices that we can make for each one of these truth values, well, we've got 2 possible truth values for P, 2 possible truth values for Q, and 2 possible truth values for R. Those are the number of ways to complete each of those individual tasks of choosing a truth value for each variable. Now, in this situation, these choices are independent because we do want to consider all possibilities. So the truth value you choose for one variable is not going to limit what we can choose for the others. So they are independent. That means that we can apply the multiplication principle to get the overall number of choices. And, we don't use this too often in college, but we'll use the cross for multiplication here. So that'll be 2 times 2 times 2, which, as you know, is 8. Okay, so there are 8 possible combinations of truth values for the values of these 3 variables. And that means there will be 8 rows in the truth table. Now, I claim that there is a better way to write 8 here. And if you want to think about that for a second, you can pause the video. So really here, if we want to preserve the pattern, the best way to think about 8 here is that it is 2 cubed. Okay, interestingly there, we see the number of variables showing up, and then of course in our base, the number of choices that we have for the truth value of each variable. Okay, so let's kick this up. Generalizing it, suppose now that we had a formula with n variables. So here n can be any positive integer. So how many rows is the truth table for that formula going to have? Can we give a general result here? Again, if you want to think about it, you can pause the video and do so and come back when you're ready. Okay, so we would have again a similar setup to what we saw above. We'd have one of those blanks to fill in for each variable. That's n blanks, 2 possible truth values to go in each blank. And so that means that in this situation, we will get 2 to the n possible combinations of truth values. And that means that the truth table will have 2 to the n rows. Okay, so quickly, truth tables will get very large. You probably don't want to go beyond like 3 or 4 variables in one where you're actually going to draw out a truth table by hand because, yeah, they grow exponentially with the number of variables. Okay, it kind of hints that maybe truth tables are not going to be the most efficient way to answer questions about truth values in the long run. We'll see other options. Okay, there is one other thing to address here now that we know how many rows our truth table is going to have. That is, how do we organize the rows in a truth table? Okay, now you could argue that I should be able to put the rows in any order I want. Okay, now you would be correct from a substance perspective. Okay, from the perspective of what information does that table contain overall, it's going to have that same information no matter how you organize the rows. So that doesn't matter for that, as long as you complete each row correctly, of course. However, correctness is not enough in our work, in our mathematical work in this class. Clear communication is also essential. And it's a communication consideration that causes us to be more particular about the order that we fill in these rows, or that we put the rows in. So for clarity, here is the convention that we will always aim to follow and should follow in this class, which is that we are going to put the t's, the truths, as close to the top as possible as we are filling in our variable truth values from left to right. So we've already kind of seen this in another video. Perhaps I won't dwell on this too much. But let's suppose again that we have three variables, P, Q, and R. Well, we're going to have columns in our truth table for P, Q, and R. And so for P, we're going to start on the left, and we're going to put our trues toward the top. So P is going to be true half the time and false half the time. And so we want to put the trues on the top half. We know that there are going to be 4 rows in the top half and 4 rows in the bottom half because there are 8 overall. So we put the trues in the top half and the falses in the bottom half. Now moving to the right to Q. Okay, we now want to put again, so P could be either true or false again. If P is true, Q could be either true or false. And we want to put the trues toward the top, falses toward the bottom. Now in the situation where P is false, Q can also be true or false. So we put our trues toward the top and our falses toward the bottom there. And then with each combination of truth values of P and Q, R can be either true or false. And then again, in each of those scenarios, we put the true above the false. And so we end up with a setup like this for the possible combinations of the truth values of our variables. Okay, so this format, for one thing, it helps ensure that we get all the possibilities. We know there are 8. We don't want to miss any. We don't want to double include any. So being systematic like this about it will help ensure that we get all the rows that we need exactly once. Okay, and this order, again, it's the order we should use, and you can extrapolate it to other numbers of variables as well. It's crucial for communication. Okay, if you use a different order, your table might be equivalent to someone else's, but it might look very different from everyone else's, and it's going to be very difficult to figure out what's going on if everyone kind of puts the rows in whatever order that they feel like. So I definitely will ask and expect that you stick with this particular order. Okay, is there something else? Let me think. Yep, I thought of one more thing. Okay, how do we know which variable goes in the leftmost column? And what order these variables go in for our columns? Well, our convention is going to be that we put the variables in the order that they appear in the formula, okay, or in the argument or whatever. Whatever appears first, that's what we put first. That is going to be a consistent way to do it. Okay, alphabetical order or something like that, not necessarily going to be consistent because different people might choose different letters to use, different variables to use to represent natural language sentences. Okay, so we go in the order that things appear, and again, that will help keep us consistent in organizing our truth tables. All right, hope you enjoyed that, and we'll see you again soon.